Good morning, friends. Cis and trans nomenclature of the geometrical isomers of the disubstituted and trisubstituted ethene. At ABC is equal to C, AB and ABC is equal to CDB. Respectively, the isomers which contain at least two similar groups on the same side is called as cis isomer. The other are called as trans isomer. Cis isomer malic acid, trans isomer fumaric acid. Z and E nomenclatures. The group attached to each of the double bond are imaging according to the decreasing order of number. The position of the groups of the higher priority attached to one of the carbon atom compared to similar higher priority groups attached to the higher carbon atom. The three highest priority are the same side, then the structure assign their Z form. If they on the opposite side, then it is designated as the E form. E form, Z form. Examples are given here: E form, Z form. Conformation of ethane. Different conformations, that is arrangement of the atoms of the molecules in the space obtained by the rotational about the single bond, are called the conformations or the conformer or the rotational isomers. In ethane molecule, two methyl groups are attached by the single bond by rotation around the carbon-carbon single bond followed by two conformations are considered, that is the staggered and eclipse. Sahas projection formula: eclipse form, staggered form. Newman projection formula: eclipse form, staggered form. Staggered form is the most stable conformations in all the atoms are far away from each other. Rotation of the one carbon anion clockwise or anti-clockwise, we get another conformation in which all the hydrogen atoms on the carbon atoms are directly opposite each other. This conformation known as the eclipse form. Vertical hydrogen atoms are at the close distance in the eclipse form than the staggered form, hence the eclipse form experiences the repulsive interactions. Therefore, the eclipse conformation is of the higher energy than the staggered form. If you go on the rotation, the front carbon atom still 60 degree, we get the 3 times staggered and 3 times eclipse form. All the staggered form are of the same energy like the vice. All the eclipse forms all are same energy because the same substituent attached to the carbon atoms. The potential barrier to these rotations will have the three equal maximum, that is 60 degree, 180 degree, 300 degree, and the minimum 120 degrees, 240 and 360 degree. This is diagram for the energy profiles and the conformation of N Butanes. Conformations are the eclipse, staggered. Conformations of the C1 and C2 bonds. Here are the conformations are given. For the staggered form is the most stable conformations and all atoms far away from each other by rotating to the clockwise or anti-clockwise direction. The another conformation, that is eclipse or the staggered. The eclipse conformation is less stable due to the repulsion potential energy change on the continuous rotations, which represent the profile energy profile diagrams. Conformation considering rotation of the C2 and C3, the syn peripleral, synclinal, Gauche, and the antiperiplanar, anticlinal, synclinal. N butane has the sixth conformation due to the rotation C2 C3 bond in which the eclipse and the staggered. Antiperiplan conformation fully staggered. It is extreme staggered conformation which Both the methyl groups are as far as possible. This conformation has the minimum energy, has the maximum stability. Synclinals. Both the third and fourth conformations are equivalent. Both the methyl groups are close to each other. These conformations are also called as square, for they are having the higher energy than the fully staggered form. Energy difference between the anti-periplanar and the syn-periplanar is 0.9 kilocalorie per mole. Anticlinal conformation eclipse second and fourth in these forms hydrogens and the CS3 are eclipse. Energy difference between the anti-form and eclipse form is the 3.4 kilocalorie per mole. Syn periplanar full eclipse we form in the syn periplanar. Both the large trieste groups are eclipse and hence there is a strong repulsion between them. Hence the syn periplanar having the higher energy and the less stability. Energy difference between the fully staggered form and the fully eclipsed form is 4.5 kilocalorie per mole. EPD indications energy profile diagrams is here defining all these things. So, friends, this will be the theoretical part.
Now, butane is a pretty typical hydrocarbon for you to encounter during the early stages of your organic chemistry course. And it's ever so slightly more complex than ethane in the sense that it doesn't have just 6 hydrogen substituents around its central carbon atoms, but rather 4 hydrogens and 2 methyl groups. And that adds a whole new level of complexity to its conformational analysis. And we're going to take a look at that in just a moment. But first, let's get a quick refresher about how to do a conformational analysis using Newman projections and the simplest possible example of ethane. Okay, so the conformational energy diagram for ethane looks something like this, with an energy axis on the vertical and relative rotation plotted as my independent variable. And when I look at a molecule of ethane down the carbon-carbon bond like this, I can clearly see why we have local minima and maxima. The local minima in the energy correspond to the staggered conformation. And a 60-degree rotation leads me to the local maxima, which are the eclipsed conformations. And in the case of the ethane molecule, I can do this pretty quickly because all 3 of those staggered and eclipsed configurations, relatively speaking, have the same energy. But this is not going to be true of butane. So let's take a look at what happens when we add something besides just hydrogens to these 6 positions that stand out during our Newman projection. So now let's take a look at butane, which is a hydrocarbon with the molecular formula C4H10. Now, butane looks like this, and it has 4 carbons in a linear chain. So naturally, there are 3 different carbon-carbon bonds along which I could cite for my conformational analysis. I'm choosing to do my conformational analysis along the central bond, or the C2-C3 axis. This is because it's going to give me the most interesting result when I do it. So if I cite along this axis, notice that each carbon will have 2 hydrogens and 1 methyl substituent. When I do my conformational analysis, what I see is a conformational energy diagram that looks something like this. Very similar to ethane in the sense that there are local minima and maxima, which correspond to staggered and eclipsed conformers. And yet somewhat different, because if you look closely, you'll notice that not all of the staggered conformers have the same energy, nor do all of the eclipsed conformers have the same energy. So there's something more going on here in butane than there was in ethane. And in order to explain this better, I'm going to have to turn my molecule on its side and cite along the carbon-carbon bond in a Newman projection orientation. And when I do this, as I've drawn it, you can see very clearly that the 2 methyl groups are at a 180-degree dihedral angle to one another. So they're as far apart in space as they can possibly be. When we have a molecule like butane in a conformation in which the largest substituents are as far as possible from one another, we refer to this as an anti-conformer. The anti-conformer is, of course, the lowest energy conformation possible, because there's as much space as possible between the largest groups. A 60-degree rotation of the carbon-carbon bond leads me to my first eclipse conformation. And you'll notice that although this is higher in energy than the anti-conformation, it's not yet the highest energy conformation because my methyl group is eclipsing a hydrogen. My next 60-degree bond rotation leads me to another staggered conformer. But in this staggered conformer, you'll notice that the methyl groups are getting very close to one another. So when we have a situation like this, where our bond conformation is staggered, but the largest groups are adjacent to one another, we call this a gauche conformation. And it's slightly higher in energy than an anti. Proceeding through another 60-degree rotation takes me to my least stable conformation, one in which the two methyl groups eclipse one another. When the two largest groups eclipse one another, we refer to this as a syn conformer. And the syn conformer is always the highest energy possibility. Another 60-degree rotation will take me back to another gauche orientation. Yet another 60-degree rotation leads me again to an eclipse conformer in which my largest substituents are eclipsing smaller ones. And my final 60-degree rotation will bring me back to my starting point in an anti-conformation. So as you can see, it's all about the relative position of the larger groups in our Newman projection that tells us whether we're in anti, eclipsed, gauche, or syn conformation. And a molecule like butane is an excellent example of this. Hope this was helpful to everybody. I'm Professor Davis from chemsurvival.com, and you